Hey, welcome back to another episode of Aptera Reboot. Oh man, it feels like it's been a very long time since the last post. I just took a little vacation with the family and I just came back right on time to catch the Denver Electric Vehicle Council with CTO with Aptera CTO Nathan Armstrong. I gotta tell you, this was possibly one of the best webinars I've seen yet from Aptera. There's a lot of great new information. We get to find out that the Aptera can actually float, so that's some new information there, for me at least. We also get updated information on the expected delivery dates for Aptera. In addition to that, we get an update on the 0 to 60 speed. It's actually going to be under 3 seconds. Man, I gotta tell you, this is one worth watching. This was a pretty long webinar filled with a lot of great information. So what I'm gonna do is I'm going to split this into two parts, and I will add the link to the second part to the video. Just take a look somewhere on the screen. You should see a link for the second part. Don't forget that we need your support. So if you enjoyed this, hit the like button, hit the subscribe button, hit the notification bell, and also support us on Patreon. Check out our merch store at apterareboot.com. We just got some new merch there. I hope you guys enjoyed this webinar as much as I did. A big thank you to the Denver Electric Vehicle Council for hosting this. Fantastic job, guys. Great questions, great people. I really enjoyed participating in this. All right, so with that being said, here we go.
Hello.
Howdy.
Hello.
We still got people coming in, so we'll crank things up here in just a few minutes.
Good evening.
Good evening.
Oh, there are people in there.
Yeah.
Go to the gallery, yeah.
So you folks are in Denver, is that correct?
Yes,
correct.
for the Denver Electric Vehicle Council. We were founded in 1974. And so we've been looking along here for going on our 46th year or something like that.
Well, that's the year I was born, so I can tell you it's 47 coming up. So wow, that's incredible.
Mm,
And we got a whole bunch of people coming in here all at once.
yeah, she probably jumped
This
on
looks
here
like
in a minute.
the biggest crowd we've had so far. So Julia picked a good one to draw a crowd.
Hello, everyone.
How's Jill today?
Hello.
Good. I'm good.
Hello, Jill.
Hi.
Okay.
Wow.
Hey, aloha.
Hey, there's Tim.
Thanks for inviting me.
Hi, Tim.
Hey.
And we're covering clear out to Hawaii today.
Yeah, excellent. Well, you know, Aptera's got coverage even in Hawaii.
Yep.
Oh, got to be impressed. You got Denver, got me all the way over in Virginia, and you out in Hawaii. Perfect.
Yep.
I'll be right back.
Okay. I'll just watch and I will.
Now we're going to be bringing in Wild.
Who's there?
We may just give it a couple of more minutes here, because we still got some people coming in. Looks like we got a lot of new faces here tonight. My name is David McNeil. I'm the Secretary, Treasurer, and Newsletter Editor for the Denver Electric Vehicle Council. And Julia's been setting us up with a monthly meeting, and we have this special one tonight with Aptera. So that's cool. And I think probably at this point in time, what we'll do, Julia, is I'll just turn it over to you, and you can kind of introduce the speakers tonight, and we'll just kind of go from there.
Okay, so Nathan Armstrong is a mechanical engineer, I believe, for Aptera. And Aptera, for those who do not know, is an electric vehicle company in California that is producing a solar-powered, at least a 30-mile-a-day solar-powered electric vehicle, also plug-in, that gets 1,000-mile range. It's extremely aerodynamic. It's extremely light. It's extremely strong. It's got a lot of interesting things about it, and Nathan will tell us about how it was designed and how it was engineered.
She comes in late.
All right. Should we just dive right into it, Julie? How do you want to do this?
Oh, I'm going to start the record here so that we can record it, and we're ready to go. So go ahead, Nathan.
Oh, well. Hello, everybody. Nathan Armstrong here from sunny, just outside of Calgary, up in Canada, where we have we call it West Coast and North facility, where we have a composite shop, R&D shop, test track, and a few of the neat facilities up here. I'm actually CTO for Aptera. I've been with the company since the very beginning, back in 2003, when we tried this the first time. Yeah, I'm very familiar with the vehicle, very familiar with the story. My background is I was an aerospace engineer initially. Then I got a job for a company called Metal Crafters in California, where we made concept vehicles for the major OEMs. So I started there in like 96 as like the mechanical engineer. That really annoyed all the old craftsmen that was in there. I was like the young CAD guy that came in and kind of like, caused a lot of problems for the existing trades. But we started building concept cars, designing them on the computer. Did that for 15 years, building concept cars, and then had my own company doing vehicle design, development, and now with Aptera, mostly full time. So I've done about 100 vehicles, various concepts over the years, and a whole bunch of electric ones. So if you got any questions about any weird electric vehicles in the past, I might have had a hand in them. And I can give you guys a bit of the history if you want, of kind of like how the Aptera kind of came to be. And I got some other interesting stories like around the Volvo 3CC, some of the vehicles that we did back in the early 2000s that you might find interesting. But the suggestion from the Aptera crew was to just open this up to questions right away, and let's just kind of get into a bit of a story and see what we can dig up.
Would it be possible, because I think a lot of people have never seen this vehicle before, would it be possible to do you have like a video or something that you could show us as a start?
I talked to Sarah about that, and she said the best place to go is actually the Aptera YouTube channel, because we keep posting a bunch of stuff there. So if you want, I can pull up some videos and share my screen. We had one at the test track the other week that was pretty good. So I don't know if you guys have seen any of those videos. We could show a video, or you guys could just look at it on your own time kind of thing. What do you prefer?
Why don't we just start out by showing it, just so that people, once they see it, I think that will elicit some questions for people who haven't seen it before.
Sure. I'm going to get commercials here. You guys see that?
Yep.
All right, so this was at the test track about 2 weeks ago. We're just doing quarter-mile tests, and we're doing moose tests, and we're doing all that kind of stuff. So this is prototype number 1 of what we're calling the alpha design, which we started in late 2019 and finished building that vehicle middle of last year. We're getting great performance. It's an evolution from the vehicles that we did 13 years ago. So we weren't expecting many surprises. The main difference between this one and the last one is we're using in-wheel motors this time, which is an incredible thing to be using. Anyways, that's the vehicle. It's kind of a strange looking thing. It's basically based on Steve Fambro, who was the founder of the company. He was inspired by sharks. And now sharks, when they come down to the ocean floor, they actually have to arch their backs up to overcome the ground effect, and it allows the water to go underneath the shark's body. So it's basically like a cambered airfoil. But Steve kind of figured if this was the most optimal shape, like why not design a car using like the most optimal shape possible? And that's where the original design came from, and it's evolved throughout the years, and it's gotten a bit bigger and a bit fatter to fit more batteries and a bit longer. And but we've always maintained the coefficient of drag. We're at like 0.128 now. The first car was 0.09, which was less drag than a 12-inch cube. And the other one we like to reference was less drag than a windshield wipers on a typical vehicle. The goal was always to create the most efficient, lightweight, safe vehicle possible, kind of thing. So that's the Aptera.
So how does it get the 1,000-mile range? What goes into that?
Well, the vehicle itself obviously is super efficient, right? Like we're getting 1,000 miles on the same size battery pack that a Tesla Model 3 is getting, 400 miles on, just because of the efficiency of the vehicle. So it all comes down to lightweight aerodynamics and using power efficiently, right? So we've got very smart systems around regen. With the in-wheel motors, we can capture a bit more than a regular EV. It's just. I mean, the whole vehicle weighs 1,600 pounds. It's incredibly lightweight. It's basically like an airplane with wheels. But a very advanced structural monocoque. We use a multi-piece construction where we end up with like this beam system around the cabin, and then we inject foam into all that. So it basically becomes like a big motorcycle helmet when it's done. And when we tested the cars years ago on the crush test jig, we were 6 times above the vehicle weight, which was a record for vehicles at the time. And the spec is 1.5 times vehicle weight. So it's extremely strong. And the other big breakthrough that we found was when we compressed the body. So we had it on a big fixture with a big plunger that cracked the body in. When we cracked the body in, we got the force reading, then we pulled the plunger back. The whole body like popped back out, like the whole thing returned back to its original shape. And that was a really huge moment for us, because that means from a safety perspective, not only can you control the energy absorption and you can direct where it goes, but then after the impact, it's going to return back, which means you're not left squashed in you're not crumpled up inside a car kind of thing. So from a safety perspective, that's a massive breakthrough, we feel, that you're not going to have these issues. And of course, it's resistant to hail, it's resistant to, rust, it'll never rust. We're essentially designing the main monocoque to last indefinitely. So the goal is that the vehicle will last, give it to your grandkids kind of thing. And then we're using a lot of natural fiber-based materials for the body panels going to get broken, like the skirts that are going to get impacted. And we're using natural materials in the interior that are also biodegradable. So every 5 years or so, you could do a refresh on your car, get a new interior, get some new panels put on kind of thing. But the main monocoque is designed to last forever. Sandy Munro is still affiliated, yes. They actually invested in the company. And we're working closely with those guys to bring it. Yes, we do have airbags, actually. We have airbags in the seat belts, which is a vehicle-approved method of doing seat belts for a low-volume manufacturer. So we have airbags.
So in a crash, are certain components designed to crush to absorb energy so that you're not transferring momentum to the passengers?
Mm-hmm. Yeah, in the front, we got a traditional kind of subframe with a crush tube structure, with a traditional kind of a bumper. So on a front impact, it's more like a regular car. And then the rest of the vehicle, the side impact is all composite. There is all composite, but it's all tuned to, like I say, take the load and distribute it around the body in a way that's controlled. And very effective. Like it's an extremely effective, safe monocoque. You know, it's more like a race car kind of thing than a regular vehicle. Yeah, service. So we're a big fan of ride to repair. Like we're all mechanics, we're all hobbyists, we're all tinkerers, right? We're all crazy, whatever guys. So we all like working on our own cars, and we don't agree with this like not ride to repair thing. We're making the car as accessible as anybody wants it to be. So depending on how deep you want to get into the vehicle and play with the systems, it's all available. The plan for service is something kind of like Tesla has, where bands will come out and do kind of things. But we also want to promote self-service. We want to promote people fixing their own vehicles if they can. If it's something simple like a door handle, you know, or something like a wiper arm or something like that, you know, it's a very easy fix. And even more complex mechanical systems like the getting into suspensions and stuff, like the vehicle is very simple. I think people are going to be surprised how, you know, how basic it is. And not from a basic because it's like not well thought out, but basic because we're kind of following the Lotus ethos, right? Simplicity, lightweight, reduced part count. So it's going to be a very accessible vehicle to work on, and we really think that people will, you know, become and tune them and have some fun with them, right? That's kind of the idea.
So how close are you to actually getting into manufacturing?
Well, the plan is to build a limited number in January that are going to be for the public, and then a larger number in February, and then an even larger number in March, and then by June we'll be in full production. That's the plan. So it'll be a vehicle every 3 minutes by June. Until then, we are going to be delivering custom vehicles in January. So that was the promise, and we are going to follow through on that. No, this is the crazy time right now. Like it's 24/7, and everybody's jumped through every hoop you can imagine. And we got new people joining the team. We're getting exceptional people joining the team. A lot of aerospace guys, a lot of guys on really interesting projects in the past that are coming to the team because they're really passionate about this project and how it's going to go. So that's been amazing, actually. How are the seats for long distance driving? They're great. They're 6'6" is what we are designing for. So a 105th percentile male is the largest. The battery cooling system is a fun one. So Steve is a aerospace guy. He was a pilot, and he's got big into skin cooling. So we've got this crazy system of channels laid into the belly pan. Basically we run the fluid through that, and then we've got a surface coating that transfers the heat into the composite, and we're actually able to transfer enough heat out through the skin to cool the batteries. So it's a skin cooling process that we're using. So it's aircraft technology. There's an interesting question on the uphill thing there. Again, the lightweight works in our favor here, right? I mean, with one passenger, you're going to be 2,000 pounds. Going up a hill, you're not going to have the same pull from gravity as with a 5,000 pound vehicle, obviously. So, but we'll have to quantify that, see what that works out to.
I'm going to go back. There was some questions in chat earlier, and I just don't want to miss them. So one person was just trying to confirm, when you say 1,000-mile range, do you mean one could drive 1,000 miles nonstop?
Mm-hmm. You know, that was one of the crazy breakthroughs back in, I guess, the end of 2019, early 2020. We started looking more seriously at packaging the batteries and how we're going to package the batteries and how we're going to package enough batteries. And the beta car that you're going to see coming out, even later this year, September, October, we'll see the first examples of the final design come out, and you'll see the belly's a little bit bigger than the current vehicle to fit more batteries. But it was just a matter of, okay, so we can fit this many batteries, and then you run the calculations through our efficiency calculator, and it turned out the range was about 1,000 miles. Like it was just one of those things when we plugged the numbers into the simulator, and it was like, wow, that's crazy, you know, that's really crazy. Like that's it really. And then we ran it again and again, and it was like, yeah. So it just comes purely down to how efficient the vehicle is. Like it's not a huge battery pack to get that kind of range.
May I just ask a follow-up? So the efficiency, can you measure it in miles per kilowatt hour, or how many kilowatts the battery has?
Yes, and I could give you the number, but it's a moving number at this point, and not something we really want to share. But it's it's a fraction of a regular vehicle. Like, it really is an astonishing orders of magnitude more efficient than a regular vehicle. It's more efficient than riding a bicycle, put it that way, for a calorie per mile usage. It's so.
Why 3 wheels? Just to make it light and less tire cost?
No, actually, it was purely a chase to be the most efficient vehicle possible. So obviously, 3 wheels, you have less rolling resistance than with 4. Aerodynamically, it's not that much of an improvement, because with the 4 wheel, you put the other wheels, like the rear wheels, are behind the front wheels, kind of shadowed. But from a rolling resistance standpoint, it's a huge gain, and then from a brake drag standpoint, it's a huge gain. So that was kind of the main thing. And then, of course, it's an easier market to get into. So we registered as an autocycle right now, so you can ride the vehicle with a motorcycle license. But it was mainly due to creating a vehicle that we felt was the benchmark in efficiency, right? Like, this really is like it's an example of what could be done, kind of thing. Like, we don't think it's the most efficient from a passenger standpoint. Obviously, it's only 2 seats. 4-passenger vehicle will be more efficient. 4 wheels is more kind of mainstream, so 3 wheels can have less acceptance into the market. But we felt we wanted to make a statement. We wanted to show how, through intelligent design and through intelligent use of materials and whatnot, you could actually achieve an orders of magnitude improvement over efficiency than anything on the road today. And we just felt there was a massive low-hanging fruit that someone had to pick. I mean, as cars get heavier and heavier, it just seems to be going in the wrong direction. So, so the next vehicle after this one is going to be a 4-wheel vehicle, 4-passenger vehicle, but using the same principles of lightweight, aerodynamics, and all that kind of stuff. Lithium ion, yes. Yeah.
Are there any plans to have a smaller battery pack? Obviously, that much range is really not necessary. Even the current EVs of today probably really don't need it. So what's your thought on that?
Oh, no, we got 3 different packs. We got a 350-mile pack, I think 600 and then 1,000, something like that. But of course, as you get lighter, as you put a 300-mile pack in, now your efficiencies go up, right? Because your battery pack is a third of the weight, and of course, everything gets lighter and more efficient. So, it's one of the things where the lighter pack actually, it's not that you get less range, right? Because now you have less weight. So,
yeah, no, that's kind of what I was thinking is, back to our American, everything bigger, it doesn't always have to go that way. So that's great to hear. Thanks.
Yeah, for sure. And then with the solar panels, of course, we're getting, 35 to 45 miles a day of charging in ideal conditions, right? So that's, that was another one of those things that we looked at the solar panels and we said, well, it's a bit, like the solar car stuff. I mean, it's like, it's great and it's fantastic and we all love it. But does it have a practical application? And on the very first car, we had a solar panel and all it did was recirculate air into the windshield. So like from a climate perspective, all your heat absorption and interior comes into the windshield. So if you just create an air pocket there, you stop that radiation coming in. So we had a solar panel just to run a little fan to make this like heat curtain kind of thing. But then other guys were coming out, the Fisker came out and they're like, oh, with solar panels you can charge the car with. And it was just a joke, right? So we're like, we got to be really careful about what we say about solar panels because it's like, we could backfire. But then we set up an experiment and we had it running for 6 months and we did the numbers and it was like 40 to 50 miles a day of charge time. That's like 2 gallons of gas in your car when you come out from work. That's magically in your tank. So we felt, for the cost impact, it's a few $100 per vehicle. There's a bit of technology challenge, like getting the panels to infuse with a composite. And we're working on 3 different ideas how to do that right now. But we're really hoping like the solar film technology or like the nanodot technology gets going because working with the cells now is a bit of a pain. But the end result is you get a significant amount of charge. So it's worth it, right? And it's really not a weight penalty. So handlebar or steering wheel, conventional. It's a normal sort of looking interior.
What about crosswinds? I picture myself driving from Denver to Santa Fe. You hit those flat areas in New Mexico. You're doing 70, 75 miles an hour. It's maybe on the slower end. And you get a nice little crosswind. And the car looks very aerodynamic. Do I need to worry about getting blown off the road or anything?
Absolutely not. No, it works the other way. I mean, the car's aerodynamic in every direction. So crosswinds. Yeah.
Makes
like
sense.
when we went out testing with the first car, we came back and went through a bunch of flies, and there was just a few flies stuck right on the front of the car, like right on the front of the nose where the pressure point is, and they just blew over the whole rest of the vehicle. Same in the rain too; it just blows over the vehicle. It really is like driving an egg when you're in it. It's really quite a weird sensation, but it's quiet. It's dead quiet. It's like being in a glider. It's a neat experience. And of course, the composite body, like we have a metal subframe and a metal rear subframe, but the whole monocoque is composite foam filled. So the resonant frequencies are almost nil. Like we have no harmonics going on in the vehicle because the material deadens so well naturally. So it's quiet. It's absolutely quiet. It's really cool. But yeah, crosswinds no problem. Rear winds no problem. Vehicles going fast, trucks going fast, no problem. A little bit of a sail, yeah, but compared to a regular vehicle, it's very minimal. It's only 2 or 3 square feet.
So somebody asked what the market is for this. So is this meant to be a primary vehicle or a vehicle where you have another vehicle in the family that is used for other purposes? Is it a practical community vehicle?
I see it as a vehicle for all the real tech nerds out there. That's what I see it as. A vehicle for all the people who just love something crazy and love something unique and love something that's like different and an improvement, right? Like I got a friend with a Tesla Model S, and she said it's not only the best car she's ever owned, but it's the best object she's ever owned, right? Like that to me is like an incredible testament to the vehicle and kind of like what we're going for. So yeah, it was just for people who really get it and really get kind of, want to make a statement kind of thing. Absolutely regular vehicle, you can use it every day, you can drive it wherever you want. So a lot of the interest we get in people who want to do long trips and then people as a commuter car. But a lot of people buying it because they want to do long trips and long voyages kind of thing. So that's and because of the efficiency we have as well, if you do plug it in a charging station, for 20 minutes, you get a much further range with our vehicle than 20 minutes in a regular EV2. So your charging times become much shorter as well.
Any tests on snow?
Not yet, but we've tested on cold weather lab, and we've done testing on pretty inclement weather, but not deep snow yet. No. But what we expect to happen is that the snow will get packed up inside the skirts. So I live in Calgary, so I mean, obviously you see snow quite a bit, and you see vehicles with snow packed into the wheels, and it just gets packed around the wheel arches and eventually falls out, kind of thing. Like we're expecting the same kind of thing to happen with this. Not a real concern.
Can you say anything about safety measures?
And we're like I said before, the vehicle itself is inherently ridiculously safe, and we're very proud. It's really one of the things that, like personally, like I got kids, like we've all got kids. We all want everybody to be safe, and car accidents are, they're unspeakably horrible. So we want to, and we're building cars. I mean, this is serious stuff. So, we want to make things as safe as absolutely possible. And we, from the tests we did years ago, like I say, we were breaking records in body strength. There wasn't any vehicle at 6 times vehicle's weight on the A-pillar crash. Like I say, with the composites bouncing back to its original form, like that to me sold me on the composite thing. Like it was all good until that point, and then it was like, no, this is great. Like now this is incredible. So the vehicle itself is very safe. We've got seatbelt airbags. We're basically designing everything on the vehicle to meet motor vehicle safety standards, like passenger vehicle safety standards. Like that's our target kind of thing. And our real target is to supersede those. If you look at like a traditional car maker, a lot of the money spent in engineering is really spent to try and get down as close as possible to the safety margin. And if you talk to race car guys, they'll tell you that the vehicle safety standards are like really low. Like race cars are 1,000 times safer than a passenger vehicle. So there's a lot of margin there to play with as far as safety, and we're really trying to get up on the upper level of that and try and make this thing as absolutely safe as possible. The other thing too, because we've got wheel motors, we've got very interesting options on stability control and torque vectoring and all that kind of stuff. So when it comes to an emergency situation, we've got much better control of the vehicle itself than a regular vehicle. So just avoid getting into situations as well. Don't know much about the facial tracking. The autonomy thing is an interesting one. We're working with a few different suppliers on that. It's all getting to be way more simple than it was a few years back, like all this stuff is. So it's like vehicle tracking stuff and the auto stuff, it's lots of options for what we can use it. As far as facial recognition, I don't know. But it is interesting, that one, actually, because so I'm assuming a lot of you guys are hobbyists and you've built electric vehicles and you know about controllers and you know about programming controllers and all that kind of stuff. And you guys have probably been keeping up on kind of where the control technology has been going. And you don't hear about this much in regular, because everyone has their own controllers. But for us, we've been looking at controllers and what's available. And controller technology, and this has been kind of kept a little quiet. No one's really been talking about it because I think it's just highly technical. But controller technology is I'd say doubling in capacity a year. We just finished building an e-bike project here. There was 8,000 settings in the controller. And you could tweak anything. And they're even saying that you can get rid of hydraulic brakes now using the controllers because they're so good. So these kind of like revolutionary breakthroughs that are happening through controller technology are really exciting. And the efficiencies are going up. And like I say, the people that get involved in controller design and software development are incredible. So again, we're really hoping to open this up to the people that are interested in stuff that own the vehicles. You know, you get different levels of access to the controller, but I mean, there's all sorts of fun you can have. You know, so it's really exciting. And you know, again, a bit different from other EV companies that don't give you any access at all to the controller settings. Like, we want to make that available if you have the inclination to play around with it, like, you know. So that's really exciting, because that's going to be a lot of fun, and people are going to be doing some fun things.
So when talking about control, do you all have any plans for doing anything towards autonomous driving, or just driving helps on long trips?
Yeah, no, there's, like I say, there's if you go to an auto trade show now and you walk around the floor, there's 4 or 5 companies with booths that sell the complete auto drive kit, like plug and play. Like, you put the camera here, you put the module here, and there you've got your control. So that whole side of driving technology is becoming really accessible and really quite easy. So we have power steering. We've got all the pieces on the vehicle to do the mechanical side of self-driving. It's just a matter of plugging in the whatever software pieces now. But like I say, it's becoming really easy now. Like, compared to 5 years back when everyone was trying to figure out how to do it, it's you literally just go to a company now and just buy the system and plug it in. So so there will be some level of autonomy. But, you know, again, we're not, you know, we see all the problems Tesla's having with that, right? And it's still very early days for that technology, you know, so we want to be careful there, right? We don't want to put people's lives at risk. So. That's fantastic. So how many folks out there, like, you guys all like are electric car builders from way back, or like, are you build conversions, or are you guys more just buying the, like, what does your club do?
I'm a Tesla Model 3 owner. Reserved mine right after the reveal, and I really do enjoy the autopilot, even though it's not complete. It sure makes driving cross country easier.
Yeah.
I was just going to say, I think someone was asking in the chat, and I'm also curious how you plug it in. Is it a standard J1772 and you don't have fast charging?
We are going to have options. So we've actually got enough room on the front of the vehicle where the chargers plan to go to fit 4 charging plugs. So we're sort of thinking, why not put all 4 up there? You know, I mean, it's just a matter of cost, really. But I mean, yeah. We're not a big fan of the 7072 plug, right? It's not great, but I mean, but again, because the vehicle's efficient, you plug it into a 110 and you actually get a significant charge overnight, right? So that's interesting too.
You have any price point information for the various models?
It's on the website. I think it's started 26 for the base and goes up to 48, I think, for the 1,000 mile. It's sort of in that same kind of price range. We have an interesting kind of business model too, again, because we, if you guys see what Tesla's been doing with their massive 800,000 ton, whatever, die casting machine, where they want to make all pieces of the body in like one piece kind of thing and minimize part count. We're doing the same thing through composites. So the main structure of the vehicle is like 7 pieces. I know the website says 4, but it's actually 7 pieces up on together to create the main monocoque. So it's actually a very cost-effective vehicle to build. And what we're trying to do is we want to try and help support and create more artisan labor in the workforce and in the factory environment. Right? So anybody who's done studies on workplace happiness and kind of how people feel, good about their job is when they actually get to contribute creatively, and they get to do something that's meaningful and is has some kind of skill to it, right? So we're trying to create an environment where we can have a smaller team hand making these vehicles, kind of like Rolls-Royce does, right? But the vehicle itself is so simple; it allows the price point to be low. So we're kind of employing these high-end build techniques to a kind of a mid-range vehicle, which is, I think, a new way of approaching vehicle design, because vehicles are usually so expensive to make that corners have to be cut everywhere and labor has to be cut everywhere. I don't know if you guys know the famous story about the Ford Taurus and the chrome strip down the side. It was a 2-cent chrome strip, I think. It was a big story back in the 90s about how they didn't want to do it because it was too expensive per vehicle. And we're kind of taking a different approach, like because the vehicle is inherently simple, it gives us more margin to think about building it differently. And that's been a nice, refreshing, again, taking a different approach to design reveals opportunities, right, that wouldn't be available otherwise. So we feel that like eventually we'll have a nice, like it'll be a different factory than the car factories. It'll be more like a Rolls-Royce type, handmade, people moving stuff and not having robots moving parts around because everything's lightweight. People can move it. Like the whole body tub when it's made is only 190 pounds. So it's all human scale kind of components. And we want to create jobs, right? This is kind of what we're about. So, and good jobs, like jobs that people, feel fulfilled and they feel, happy about their jobs kind of thing. So.
And it sounded like you alluded to, this open, being able to work on it. When I was a little disappointed with my Tesla when I tried to get at the CAN bus and everything was locked, and and then later everything was under certs, and so you really couldn't. Now they have some reason, over their updates, some things where you actually just have to secure it based, how are you gonna do any over the air? Obviously you need security if you are open to networks, and yet, it definitely eliminated a lot of fun out of the thing.
Yeah, I would for sure, right? I mean, it's like I got a few home builds and they're great because you can tinker with them, and it's it's like just like when you put the chip in your regular car. Like I got one of the guys that works for me, you just put a chip in his car and you go to the app, you can tune your car from your phone, and in a new BMW, right? So, I don't see why we couldn't do the same thing. But yeah, no, but how deep we go, I think, is going to be up to the consumer, right? Because obviously there's various levels you can get to on controller programming, and you can really get to a point where you can mess things up, right? You switch off the wrong setting, all of a sudden you disable the whole thing, and you don't know what you've done, right? So, but again, it'd be easy enough to have a reset, default reset. You mess with things and you just go back to factory default kind of thing. Like it's all very easy now. Like none of this stuff is complicated. Like an Arduino can run the whole thing. It's not. It's not complicated. Like none of this stuff is complicated now. Electric vehicle technology is I'm a big fan of radio control cars, and I've been racing the thing since I was a little kid. And the latest thing in RC cars is the controller is right on the back of the motor, like it's built into the can of the motor. So literally you have a motor and you plug your battery into it, and that's it. And that's your whole drivetrain. It's like we're going to do see the same thing with cars here. Like we're almost there with cars now. People don't realize how simple like they are. Like electric vehicles, like once you wire them up and the wire's happy and everything's happy, you never touch them again. Like they're fantastic, and and there's so much fun you can have with them. Like you want more torque. Like what do you want to do? It's well, like why not let people have fun with their vehicles, right? It's like life's short. Like let's have fun with them. Yeah.
The driving experience or the riding experience as you're sitting in the seats, it's designed obviously to be slipstream through, very air efficient, very aerodynamic. In terms of comfort, is it like sitting in a sports car in the sense that your legs are going to kind of be outstretched in front of you more, and that kind of thing?
It's a bit more sports carish in its seating position for sure. We've got the batteries on the floor, so we do have a fairly flat floor. So that's one compromise with electric vehicles you always end up with batteries on the floor is foot space and age point. So we always end up with a bit more of a reclined kind of a position. But it's pretty similar to a Tesla Model 3 in its layout. Like we've got basically the same brake, and there are standards out there, vehicle standards on passenger positions, and we follow all that stuff. So from a passenger perspective, it feels like a regular car from the seating position. But what's neat is the cockpit. So because you're sitting in an egg, like the shape of the vehicle around you, you can see that it's interesting. And it kind of reminds me, remember Mork and Mindy at the beginning when he comes out in the egg-shaped spaceship? Like it's kind of like, it feels like what that would feel like. You feel, and then other people freak out when you drive around, of course. Like that is one of the weird things about it. Like people have a reaction to this thing. Like I got a bunch of old cars, a bunch of weird cars, and people enjoy them. But this thing, people just don't know what to say. Like they just, you know what I mean? It's an incredible reaction you get from people. And it's kind of like seeing the future, right? Like this is kind of what I think we're doing, is that we're really showing that the current state of vehicle design is going way off the rails, right? You go back, back to the turn of the century. There's guys like Edmund Rumpler back in Germany or Austria, I think, in like the 30s, doing studies on aerodynamic forms, right? And it was all ignored. Like there was a Tatra, I think, built one of his designs. And then like the first Saab, when the very, very first Saab came out, that was an incredibly designed vehicle. As aircraft designers did that one. And an extremely efficient aerodynamic shape that eventually just kind of evolved into the 900, which lost a lot of the original aircraft kind of inspired design. And that's sort of been it, right? Like the first Honda Insight, like the very first generation Honda Insight, the aluminum one, from an aerodynamic standpoint, was like probably one of the best cars ever made. And then since then, everyone's kind of just completely missed the mark on what's possible. Like cars keep getting heavier and heavier. And really that comes down to, if you inherit a vehicle from an engineering standpoint, so you're a vehicle engineer, you work for a company, and you get to do the facelift on the new F-150 or whatever, you can't, by the nature of the project, make it smaller. So everybody just adds to it. So that's why vehicles have grown and grown and grown oversized, because every time an engineering team gets involved, they just add to it. So look at the RAV4 now to the RAV4 back in the 80s or 90s when it came out. The RAV4 now is the size of the 4Runner was back in the 90s. So vehicles are getting bigger, and that's the march that we're on, is this kind of like, and we just want to stop all that. Like, it's just crazy. Like 5,000-6,000 pound vehicles with one person. Enough people have said now it's crazy. Right? And everyone's saying it's the wrong way to go. So we're trying to just reset the whole thing and be like, look, like this is what's possible. And when people see it, they go, that's possible. You change people's minds, right? It's quite an interesting phenomenon. Yeah. Yes, so it is rather wide. It is rather wide, and that's a stability thing, also an aerodynamic thing. But it's not as wide as a sports car, like a Lamborghini kind of thing. So fine drive-throughs, we've tested it, drive-throughs, that kind of stuff, and it works. You got folks from all over the place here. You got somebody in San Francisco on the line. Vanessa Schmidt, yeah. There's been so much. Like I'm a big history buff. I love reading all this stuff, and it's there's been so many good stories through the years of amazing stuff that didn't make it to the mainstream. Eh? It's been, like there's a group here that are restoring a Mosquito, like a wooden airplane. Remarkable thing. Same thing, right? Great use of materials.
I noticed one of the items in the chat was about theft protection.
Theft protection?
Yeah, theft protection, like somebody's going to steal it.
Oh, it's the same as any other car, same as your Tesla.
The same as anything else? Yeah,
we got NFC to open the door. And then so it's all electronic, and so that's all normal kind of stuff on the safety side.
In other words, any unauthorized individual isn't going to get electrocuted if he gets in it.
You wouldn't do that. But it's dent resistant, so you're not going to get door dings, right? If somebody bumps in the parking lot, you're not going to get any impact damage. So that's nice.
Now, is the seating on that, is that side by side for two passenger, or is that inline?
No, it's side by side. It's a standard kind of two-seat layout.
Okay.
And it's the same kind of size inside as like a Honda Civic, like a first gen, second gen Honda Civic kind of thing. That's kind of what it feels like to me, like that kind of size vehicle. And in fact, the first Honda Civic, the one with like the hatchback, had a fantastic kind of cargo area behind the seats. We're kind of similar, and we're bigger there, but similar kind of layout to that vehicle as well.
And another question here is about, is this going to throw, as it was put, befuddle a car wash? This isn't something you want to take through a car wash, I bet.
I guess you could do it if the width was okay, but there's no reason you couldn't. Like, it's as durable as any of the vehicles, so. Yeah. Battery warranty. That's an interesting one. Have you guys been following? So the trends in battery technology really are getting to now where the charge cycles are going way up. And there's a lot of talk now about batteries that are going to last, 3 times as long as the vehicle, right? So there's also talk about amortizing the cost of the battery over like 3 vehicles, and so like the vehicle wears out and you just move the battery to the next one, kind of thing. And that seems to be coming along fairly quickly. So battery warranties are a hard one. Right, but it's definitely getting to the point, especially with solid state batteries, where and the battery management systems are so good that it's crazy where batteries are going, especially solid state batteries. I see Nissan's coming out with a solid state battery vehicle now, and that's mind blowing because how you get a supercapacitor to hold a charge, I have no idea how to do it. It's incredible. But solid state batteries are incredible because they'll take millions of charge cycles, right? So
essentially, is this 2-door with storage in behind the front seat?
Yep, it's got to be kind of a hatchback on the back, opens up. You can actually lie down and 2 people in the back. It's big enough to lie down.
Okay.
Yeah. So it's a pretty good size. Our life on the electric motors. We're not sure yet. This is brand new territory, this wheel motor stuff. We're working with a company in Slovenia called Elafe, who are the world leaders in wheel motor technology. And their stuff is incredible. And what's neat about the wheel motors that I realized after talking to these guys is that the motor itself isn't stressed. So all of the load from the wheel just goes through the hub, through the bearing like a regular vehicle. And the whole motor is just along for the ride. So any road impact, any impact of the wheel, curb impacts, that kind of stuff doesn't load the motor itself. So there's no like loading that can actually impact the motor. And it's protected inside the wheel. So it's quite remarkable,
Is this a brushless DC motor or is it a AC motor?
No, it's brushless DC.
Brushless DC?
Yeah. Cargo area at the back. Actually, the guys, so we're building a vehicle right now in San Diego, and the guys actually put a frunk in there. So they figured out how to repackage stuff around the front enough to get a little frunk. So apparently we do have a frunk now. Whether or not that makes it through to production, I don't know, because there is a lot of stuff. Being a 3-wheel, you got to package a lot of mass up front as much as possible. Right? So you got to get your 75-25 weight distribution. So the front's pretty tight, full of stuff, but apparently now we have a bit of room, so we might have a little frunk.
Now,
just one of the cool things about electric cars.
One of the earlier questions I saw was, would this be in a dealer network or is this going to be direct from the factory type sale?
I don't know yet. I believe at this point it's all direct from factory. Like we're just going to be supplying customer orders for the first, we're like 1,000 orders now, right? So
yeah,
that'll just be fulfilling those orders until we get to that point, and then.
Do you have any idea about how many reservations you've gotten so far?
Yeah, last night we were over at 11,000 when I checked last week.
11,000?
Yeah.
Wow.
Yeah, so it's amazing, eh? Like that was really surprising.
Yeah. Well, I see from the participation tonight that we've got 50 people that have come on the site, and so there is definitely a lot of interest in this out there.
I know, it's fantastic, right? What kind of tire? Regular tires? They're just 16-inch rims. Nothing special about the tires. Yeah. We didn't want to make it so we had to get a special tire somewhere. We wanted to make it so you could just get anywhere and get a tire for it.
Yep.
No, I love what you said about people being able to work on it. That's one of the big frustrations about every other car these days.
I know. And they're so simple to work on too. That's the thing, right? Like it's not like you open the hood of your gasoline car and try and do something. I mean, it's really all software, right? And then if do you have any mechanical challenges, it's going to be something very, simple to fix, right? So like the part count on our car is a quarter of regular car. So just inherently less parts to try and fix. So Yeah, no, even like if you get into an accident, you want to replace like some damaged stuff, right? Like all the body panels, like because it's composite, you wouldn't, like people said you could repair it, but really it's like a motorcycle helmet. If you impact the major monocoque of the vehicle, you're just going to get a new one. And they're not expensive. And really the value of the vehicle is the battery first, and then the drivetrain, right? And then the interior stuff and the electronics. But the body itself is really not much value there. So to just transfer all that stuff into a new body would be a half day's job, and off you go. So that's kind of the philosophy behind all the repair stuff.
Now, is it still? I imagine it's still private. It's not hasn't gone public yet.
No, it's all private. Yeah, all private. And again, the investment required that we need to get the vehicle to production is again orders of magnitude smaller than a regular vehicle, because we don't have all the massive stamping machines, like all the massive injection molding machines. We have none of that stuff. We're doing everything very simple and very, like I say, just we want to make it all in North America. We want to make it all in US and Canada, which means that we have to be smart about what we do, because we can't benefit from the cheap labor, right? So we have to just use processes that we have that we can use, and that's what we want to do. So, example vehicle 1, I believe it's 400-mile range. Yeah.
So you gave us the timeline for this version of your vehicle, the 3-wheel version. Do you have any idea when you're going to start developing and rolling out the 4-wheel, 4-passenger car?
It'll probably be about a year behind this one, right? So we've already got like a preliminary design. We're working on a plan that we want to try and use as many components of this vehicle as we can moving forward. I don't know if you guys saw the Top Gear episode about when they compared Porsche to TVR. You remember TVR in England, a little boutique manufacturer. And the whole episode was about how TVR constantly innovated and cutting-edge technology and always redesigning the cars and always coming up with new stuff. And Porsche just made the same thing for 25 years, right? They didn't change it. And which was most successful, right? And we're seeing a lot of this where, like, it's almost like our subconscious minds, we really like things that last and don't change, right? Like, we just feel comfortable when we know that we're going to be able to get a part for that thing in 10 years from now. So what we're trying to do is create a family of parts that will be used through a family of vehicles that are all the same. So going forward, if you need to buy a wheel bearing or you need to buy a brake caliper, you're not having, like, it becomes a very simple process, right? And you can get a part from anywhere. We're trying to be as nice as we can to the person who owns the vehicle, right? Like, I'm going to own one of these things, right? I like working on my cars, and I like getting parts locally. I don't like having to wait 3 weeks to get a part through the mail kind of thing. So we're really trying to make it as accessible as possible.
So really just about a year's difference between the first car and then the next version.
I reckon so, yeah.
Ah, that's pretty good.
We're doing the 2 and 3 versions. The range doesn't, a little bit, like we're saving about 150 pounds on the back with the 2-wheel version. But the range is a little bit better, yeah. But I don't think we're going to see too many of the 2-wheel versions. I think most people are going to go for the 3-wheel version. It's quicker and it's not that much more expensive, and the safety improvement is quite a bit. Obviously, having control on the rear wheel is quite significant. So,
when you're talking about that, obviously I've never driven a 3-wheel. What is that like? Can you kind of give us some experience? What's different about it? How does it feel?
Well, the principle of the 3-wheeler is the bar stool example, right? Like a 3-legged bar stool goes to 4-legged bar stool. If you distribute the weight evenly on the 3 legs, it's no less stable than a 4-legged bar stool, right? So if you get the weight distribution right on a 3-wheeler, it feels just like a regular vehicle when you drive it. Like, it doesn't feel weird. You hit potholes that you wouldn't hit normally, obviously, and we have to account for that with the tire design and whatnot. But it doesn't feel like anything different than a normal car, especially with the 2 wheels in the front. Because if you have the front window, it looks like a normal car, a little bit different, but you can see the wheels there and thing. But yeah, it feels like driving a Honda Accord sort of a thing. It doesn't feel anything weird. And you saw in the video there, we did the moose test, and it just goes around fine. It doesn't do anything weird. So. But the in-wheel motor is the weird one, because obviously, like everybody knows, like sprung weight versus unsprung weight, right? And reducing sprung weight has always been the maxim for car design, especially for race car stuff, right? You want the wheel to react as quickly as possible. So putting the motor in the wheel, now we're maximizing sprung weight. We're going the other way from what an engineering textbook would say to do. But by putting the weight on the wheel, you get all sorts of weird things happen. First of all, you don't get any torque transferred into the vehicle itself. So all the torque is held like within the wheel, and it's all applied to the road contact patch. And all the weight is directly above the road contact patch as well in all cases. So you actually end up with a situation where you have more lateral grip than with a regular vehicle. Like, it's a very strange thing, and it feels different, because when the power happens, it doesn't happen on the vehicle, it just happens in the wheels. So it feels like it's happening out there. It's a really weird sensation. So I think that's going to be, for people, like one of the really interesting sensations of the vehicle is what this in-wheel motor thing. And of course, like, we can do things like, if you imagine you're standing still in a parking lot and you creep this forwards a bit, and you creep this wheel backwards a bit, you're actually going to rotate the steering. You're going to steer the vehicle. So through torque vectoring, you can actually like simulate power steering. Like, we still have power steering in the vehicle, but there's a potential we could eliminate it and just do the power steering through the vectoring of the wheels. Like, like, that's like, wow, okay, this is great. This is really great stuff. Yeah.
Now, in the front wheels, when you go around a corner, the front wheels, they don't tilt at all. We've got some of the best suspension people on the planet working with us on this project, and the front is very much like a Formula car, right? Very nice long A-arms, inboard springs. It's a beautiful piece of work. Yeah, so it goes around corners just fine.
Are the wheels visible to other cars? So is there would there be a problem with people not seeing that the vehicle is actually wider because of the wheels and accidentally clip it by like going slightly into your lane or at a parking lot?
Yeah, I think so. There's a risk of that for sure. Yeah. We do have lights all around the wheel skirt on the front, so at night they're visible, like a highly visible kind of thing. But through the nature of the design, having the wheels kind of stuck out in space like that, they're definitely going to get, there's a potential for them to get hit. But the whole wheel skirt is designed to be replaceable. It's very cheap. So if you do hit something, and then of course the wheel and the whole suspension is designed to be as robust as a regular vehicle. So curb strikes, that kind of stuff is all designed to be just taken with the impact. But that whole skirt is for sure going to get cracked. It's for sure going to get damaged. But they'll be very cheap and easy to replace. So it's
How does this thing steer? Is it steered from the rear, or is it steered from the front two wheels?
No, just front, regular.
Just like regular car steering. Okay.
Yeah, just regular car steering.
Okay.
Do have some, again, like if you look at race cars, they do clever things where they put the steering arm in line with the A-arm, so you don't get the drag from the steering arm kind of thing. Like, we're doing those kind of tricks. So there is a bit more thought into the suspension design, but it's one of my favorite parts of the car. Like, when you see it just by the suspension on the wheels, it's beautiful. It's like, wow. It's a shame you can't just drive it like that and show all that off. But yeah, the steering is like a regular vehicle.
I'm looking at the spec sheet that you guys have online. What I don't see, what's the ground clearance on this vehicle?
It's 5.75 to 6 inches. It's basically 6 inches unladen, 5.75 laden, sort of thing. But it's kind of normal car clearance. Those are cameras in little pods. So we're going for the cameras for the rear view. But because the shape of the body gets wider from where the mirrors are, we had to have the pods to get the cameras so you can see behind the car.
A couple of people were curious about whether it has windshield wipers and what the glass is made out of.
You were breaking up a second there. Sorry, was that about the glass or about the paint?
Sorry. A couple of questions that people are asking. One is, does it have windshield wipers? And the second one is, what is the composition of the glass?
It does have a windshield wiper. It's a single arm, standard kind of stuff. It hides under the cowl when it's not in use, so you don't get drag from it. And the glass is standard. It's a laminated windshield, and it's tempered glass like a regular car stuff. There is, because we are an autocycle, we do have the option of doing polycarbonate windows, which isn't an option a regular car maker would have, and it does save us a bit of weight, but it's not as durable as glass, obviously. So, but it is an option for us, and we are exploring that. So.
The images I saw online, it looked to me like instead of side view mirrors and rear view mirrors, you use cameras. At least that's what I was seeing. My question is concerning, again, I'm going back to snow. I picture myself arriving on a snowy evening somewhere up in the mountains. And what happens on my Tesla is the rear view camera always gets covered with snow and whatever muck is out there, and I can't use that camera when I'm backing into the garage. I don't know where your cameras are placed or if that's what I was seeing, but if you could just comment on that.
No, for sure. We've got two cameras, rear view cameras on the door, and then we've got a camera right on the back. But the reason your camera gets dirty is because on a regular vehicle, as the air exits the back of the vehicle, it creates an eddy, right, that spills off the back of the vehicle. And that eddy comes down and transfers all that muck onto the camera, right? So especially station wagons, I got a couple of Volvo station wagons, it's the same thing after a journey. The back window is just dirty because of the eddy created from the drag from the back of the vehicle. Whereas on the Aptera, we come right down to basically just enough of the room for a motorcycle plate. And then we, next to the plate on the tallest areas where we vent out the cabin air. So the cabin air actually fills in. We've got one little pocket of air with one little turbulence, and then the cabin air comes in and fills that in. So the slipstream of the vehicle basically it just touches like an aircraft wing. It just touches behind the vehicle and then just disappears. So
wow.
we shouldn't have issues with the rear camera getting dirty. There's no turbulence behind the vehicle.
All right, so this was just the first half of the webinar. To catch the second half, click on the link above or check in the description below. Thanks for watching, and I'll see you next time.